Understanding how Earth works is the key to meeting the climate change challenges ahead. After the Copenhagen summit in 2010, we must do everything in our power to make the next COP21 conference in Paris this December a success. To achieve this, we will need objective science, supplied mostly by international Earth-observing space systems.
No single agency, and indeed no single nation, can itself make all of the measurements and do all of the science to understand the Earth as an integrated system.
France and the United States are pioneers in the field of ocean science.
NASA and CNES have a long-standing, sustained, and highly productive relationship. For nearly 30 years now, NASA and CNES have explored cutting-edge technologies and delivered precision measurements in the area of ocean altimetry.
TOPEX Poseidon, Jason-1 and Jason-2 have revolutionized what we know about global ocean circulation.
Thanks to the NASA and CNES collaboration over the years, with, of course, lately, the addition of EUMETSAT and NOAA, we understand in detail the changes in sea level around the world, both globally and regionally, associated with our changing environment.
Our planet is warming as a result of greenhouse gases, the main indicator of this trend being sea level. Continuing to closely monitor sea level is therefore of the utmost importance.
Jason-3 is one in a series of altimetry satellites really to build a long-term climate data record. As new satellites come along and aging satellites are decommissioned, it's very important to not have any breaks in this measurement and launch new satellites well in time, like Jason-3.
Jason-1 completed its mission in 2013, and Jason-2 was launched in 2008 and is now in its 7th year of operation, well past its planned 3-year lifetime. To get a new satellite ready as soon as possible, we channeled all our know-how and expertise into Jason-3. There are several hundred people working on this project in the United States and Europe, and at the industrial lead contractor, Thales Alenia Space, as well as 100 at CNES, which is coordinating the system, satellite orbit operations and mission performance.
Besides sea level monitoring and its contribution to climate change research, the Jason-3 mission is set to pursue the development of operational oceanography. Applications serving seafarers, marine meteorology and many more sectors now rely on space oceanography data, so assuring continuity is crucial.
Right now, we're in a transitional phase with the R&D agencies CNES and NASA and the operational agencies NOAA and EUMETSAT. It's a close partnership addressing the key question of how to make the transition from demonstration and research missions to operational missions. That's what we did for weather forecasting with Meteosat more than 30 years ago, so now we have to do the same for oceanography.
An international community in more than 120 countries is now working towards this goal.
These have started with NASA CNES science teams and now have blossomed into thousands of researchers around the world that have now joined this group and going forward.
With strong support from this community and high-quality data and science return from the standard-setting Jason-3 satellite, close interagency collaboration will also help to prepare and accomplish new missions in the future.
The immediate future is focused on getting Jason-3 into orbit and operational, to complement data from Jason-2 and Sorel. We must then continue to build up our altimetry constellation with Sentinel-3, Jason-CS and SWOT, CNES and NASA's flagship mission set to launch in 2020 that's going to be a real game changer by measuring not only ocean topography but also surface water with unrivaled accuracy and coverage. The future is more continuity, flying and evaluating SWOT, and then conceiving the best observation system for in 15 years' time.